Here are the four kinematic equations we used earlier in the semester. You actually programmed them in Pirate. I don't know if you want to use that program again, perhaps. These equations involve the motion variables, starting velocity, final velocity, change in position, acceleration, and time. Each one of them contains four of the variables, so you need three to solve for an unknown. I will do the first one as an example right here. It's the acceleration of a 6 kilogram bowling ball on level ground that gets 114 Newton push, assume no friction. So as we've been doing, a force diagram first for the situation, and it's on level ground, so the gravitational force balances the normal force, leaving just the applied force of 114 newtons is the sum of the forces for this object, and that's 114 newtons. So if I want to calculate the acceleration horizontally, that would be the sum of the forces horizontally divided by the mass, or 114 newtons divided by the mass of 6 kgs, and that's going to be equal to 19, and the units will be meters per second squared. That is A, answer to A. Now B says if the ball starts from rest and accelerates for 5 seconds, how far does it go? Well, I'll use the kinematic equations for that. So for B, I've drawn a little picture of the ball rolling, and I put time 0, position 0, starting velocity 0, and at some later time, in fact it's 5 seconds, it's at some position, that's what I want to know, how far it goes, and it has some velocity. I just calculated the acceleration, so that's the link back to the forces. I used the forces to figure that out. So now the proper kinematic equation would be this equation here, which has all four of the variables I'm interested in, 3 I know and 1 that I don't know, and I'll use it here to solve. And now I've substituted in what I know to calculate delta x, the displacement, and I come out with 237.5 meters. How far that ball will go with this acceleration for that amount of time, and that's pretty far. That's quite an acceleration, actually. So I'll use this as an example and do the next one as part of your homework. The other part of the homework is to make sure today's assignment done in class is in form to hand in tomorrow. Good luck. See you tomorrow.